Good morning, everybody. Thank you for joining the offsite plug-and-play prefabricated opaque and transparent multi-component envelope systems workshop in the frame of sustainable places. I will just try to introduce you very briefly the schedule of our workshop. We will have at first the presentation of the 7 projects that co-organize this workshop, and some of the coordinators are here physically, and a couple of coordinators are connected remotely. Then after the presentation of the projects, we will have the first round table that has 2 components. The first is the presentation of the positioning paper that was developed as a result of previous sustainable places workshops dealing with prefabrication. And then we'll have a discussion aiming to identify criteria under which we could cluster these type of prefabrication technologies. The coffee break will follow, and the workshop will close with the second round table that will try to define KPIs for and whether we could, via these KPIs, harmonize the technologies and represent the prefab systems. So the first presentation will be the Infinite project and will be done by Stefano Avesani, who is not here but will be remote connected. Okay, Stefano, could you please go on?
Okay, so I have to.
Yeah, that's
just a moment. So he's online, huh?
Yes.
Just a moment. So Stefano, please click on share my audio and video.
Do you hear me? Good morning, everyone.
Yes.
Good morning. Yes, we do hear you.
Perfect. So thank you. Thanks for organizing this also in hybrid mode. I'm happy to share with you the Infinite project status. So as far as I understand, you will share the slide, right?
Okay, just a moment.
Of course.
Yeah, just full screen. Okay.
So just to tell us next.
Okay, great.
Okay,
so,
can you see the slides, Stefano?
Yes, thanks
Great.
a lot. Yeah, so I start, and again, thanks, and hope you can manage to hear me. So Infinite project aims started in November 2020, and is a sister project of Plural and Snare, the same call. And actually, we all had the challenge to tackle the market uptake of industrialized retrofit of existing building, targeting the NZEB performance goal. So this is the introduction slide with all the partners. We are 19 partners from companies and research centers and university and demo owners, consultancy, and I would say kind of interdisciplinary team. The next slide, please. So the overall broad scope is to increase the market uptake of such industrialized retrofit solutions. And then you see here all the specific objectives, which basically tackle the easiness of management of a retrofit, industrialized retrofit project. Then, of course, the market appeal of the industrialized solutions in terms of all-in-one prefabricated envelopes. Then to have the right business business framework for such new business, the facilitation of the demand side, activation of the critical mass, basically, and the right involvement of the stakeholders. And finally, of course, to demonstrate such an approach at European level. These are the specific objectives. And what we propose basically is this, we have called it the renovation 4.0, so merging the topic of industry 4.0, so full industrialized solution supported by digitalization and sound business model. Next slide, please. So what we want to offer is a kind of retrofit that allows to reach the NZEB target, through high indoor comfort targets and the electrification of the building energy balances. Then we have pushed a lot to have stakeholder-centered approach. So all our developments have been grounded on stakeholders' involvement and trying to develop with stakeholders the solutions, life cycle assessment, self-costing, the design for assessment, disaster optimized solution for an appealing building, meaning we are taking care, of course, also on the flexibility for architecture and the beauty of the final, let's say, retrofitted building. Next slide, please. So to do so, we have basically a panel of solutions, and you can see in this graphic representation on the left, let's say the envelope technologies that now we will go through very quickly. And then on the left, we have also a BMS system under development and also a platform for designers with the different interdisciplinary plugin. Today, I will just focus on the plug and play envelopes. So here you see the green kit. Yeah, please. Fine. The green kit prefabricated, so integrating in a facade or in a roof, different kind of greening. Here in the picture is the mock-up just realized with a living wall, so insulation, and then living wall as a ventilated facade. But we are taking care also on the irrigation and the management of the water. In the next slide, actually, you see the concept of having also gray water treatment integrated and a bioelectrochemical system to generate electricity for sensors to be integrated in the envelope. The next slides, we go to the second kit, which is basically integrating this a semi-decentralized mechanical ventilation unit, but with the plug-in of heating and cooling. So basically, the idea is to distribute heating and emit heating and cooling through this kind of machine. So a very compact heating and cooling system, all integrated in the facade. Then in the next slide, you can see our development in terms of smart window. So we are focusing on two aspects. One is the sense bar allowing, sorry, this is the slide, the second generation of electrochromic glazing as some management, some solar radiation management. And also in the next slide, there should be the sense bar, which is basically the sensing part in the window and connected to the basically intelligent management. So there is a server running on-time simulation, real-time simulation to find the best control strategies for glazing or shading. The fourth kit is a BIPV, which can be both for roof and facade integration. You see in the bottom a kind of different color and texture and final finishing of the BIPV. And the bottom right, this is the just made mock-up of a ventilated facade. You see all what is in this picture is really BIPV, so even the white parts. So basically, the company can really perform all kind of colors that you desire, of course, impacting the performance, but this is under monitoring, and so this will be also an outcome of the project. The fifth and final industrialized kit is a solar thermal, unglazed solar thermal facade with a cassette system. And this is fully prefabricated in on the facade, and allows to let's say it is thought to drive the heat pump, so increasing the overall energy efficiency of the heat pump performances. It could be also directly, let's say, connected to a thermal storage. All these kits basically relies on the concept of a prefabricated timber frame, facade, or roof, which is, let's say, our base common structure for all the kits I've presented up to now. And I think this is more or less all. Last slide is on challenges. If you move on the last slide, I've tried to summarize what we are trying to face. Beside the development, of course, there is the cost of the deep renovation. So before talking of the cost of industrialized renovation, in our opinion, it's really, we have to push all to foster deep renovation, deep energy renovation, because still the market works on a
Please
very light.
go ahead. Sorry for the interruption.
No problem. And then of course, the cost of such industrialized solution in terms of investment is still a challenge, and the weight of the facade might be an issue. So again, to conclude, we think that the challenges are the industrialization that could be really the key to drive new deep renovations around Europe, and that the requirements that this kind of all-in-one envelope systems have might be to be more standardized and to be considered in a norm as well. I hope you managed to understand my presentation online, and thanks again for your attention, and see you later. I don't hear you anymore because you are muted. Okay. Nice.
Okay, now,
Thank you, Stefano. We could hear you very well. Thank you.
Okay, now I have to change the presentation. Okay.
So I can remove Stefano.
Yeah.
The presentation is over.
Thank you, Stefano.
You go to the same presentation.
Yes. If it comes. Okay, so the next presentation will be from the Plural project, and I will be presenting the developments of the project. It started at the same time as the Infinite project and more or less, because we are all approved under the same call. It's a project that lasts for 8 months, and we are 18 partners for 5 countries. The aim of the Plural is to develop, design, validate, and demonstrate a palette of fully prefabricated off-site plug and play kits, which take into account the user requirements, and that's why we call them P&U kits. These kits integrate the different components, aiming to reach NZEB status of the renovated building, demonstrate cost effectiveness and time savings as a result of the prefabrication. As the other projects that we are presenting today, we are also looking at environmental effectiveness, cost, business models, and overall user acceptance, taking into account the social requirements. We have 3 P&U kits, the smart wall, the connex wall, and the hybrid wall that are being developed as part of the project. We have 6 demonstration sites, 3 real ones, and 3 what we call virtual, and I will explain in a minute. We are developing BIM-based methodologies for the data, for the design, and the linked to the manufacturing of the P&U kits. You're using a large data handling platform and decision support tool to support the design. We are implementing lean manufacturing principles, and training tools are also developed as part of the project. The project evolves in phases from the design to the manufacturing and validation. And here is a presentation of the three basic P&Q kits. The first one is a smart wall. It's a fully integrated, flexible, prefabricated facade, which can be installed at the exterior or the interior of the building. It integrates funk oil. It's a control system for the funk oil, linking the monitoring of the funk oil to the interior of the building requirements. Smart windows that integrate harvesting and mechanical ventilation. It is already being demonstrated at the prototype level at this stage. The second P&Q kit that we are developing as part of the Plural project is the Connex Wall P&Q, which is based on the technology of the partner, of one of the partners of the project, folding facade systems. The kit is extended to include air handling units, smart windows, and again, control systems for monitoring the indoor air quality and the thermal comfort of the building where it will be integrated. The third P&Q kit of the Plural project is a hybrid wall. It's a hydronic system that has been previously developed, but not at the prefabricated stage. And in the frame of the project, it is integrated at wood facade components, and it also includes, it is driven by heat pump, and includes also a control system and a smart window. All these P&Q kits are powered by renewable energy sources. We use PVs that are either integrated on the facade of the building or at the roof of the building, and heat pumps whenever it is required. Additionally, as I already explained, the P&Q kits of the Plural project are accompanied by smart windows that have energy harvesting potential, and also ventilated ventilation capabilities, mechanical ventilation capabilities. The so-called toolboxes are actually the control systems that couple the operation of the prefabricated kit with the building monitoring. And the data is stored in a large database, which is linked to the BIM simulation tools and the LCA tools. And we are also developing a decision support tools to prioritize and give hierarchy to the, according to different scenarios for the designers. The Plural P&Q kits will be demonstrated in 3 virtual buildings in different climatic conditions, since each of the P&Q kits is designed to meet the requirements of specific weather conditions and building typologies. The smart wall will be demonstrated at a building in Greece, which is the one you see on the slide on the left. The hybrid wall will be demonstrated at a building in the vicinity of Barcelona, in Terrassa. And the convex wall will be demonstrated at a building in the Czech Republic, where the climatic conditions are more appropriate for this typology of prefabricated kit. In addition, the external wall heating and cooling system that will be in reality installed in the Czech Republic will be also virtually installed, which means we will follow all the design procedure and the validation procedures at a building in Bern. The smart wall will be modified and demonstrated in a building in Berlin, which is recently renovated, so we will have the capability of cross-checking whether we will be able to reach NZEB conditions with this typology of prefabricated kits. And also the external wall heating and cooling system will be virtually implemented at a big demonstration site in Sweden, in Väsby. We are developing key performance indicators to demonstrate the effectiveness of the PNU kits. They refer to the NZEB status, like for instance, the U value of the PNU kits, cost effectiveness, fast track renovation, the environmental impact, and the adaptability. These are continuously monitored and improved during the stage of the project. Now, closing the presentation, the challenges that we face at the moment are, of course, linked to the current economic and energy situation in Europe, increases in the energy and fuel prices, affect the production capabilities of the manufacturers, and may eventually affect the production costs of the PNU kits. Consequence of this is the shortage in raw materials and high-tech components, chemical compounds, delays in delivery, significant increases in prices that are trying to be currently handled by the plural manufacturers, but as the situation is, we don't know how things will evolve. And also, this might lead to a lack of interest in this type of solutions due to the unstable economic situation in Europe. So this concludes the presentation of the plural project. The next project to be presented will be Ensnare and will be presented by Federico. So I will give the chair to Federico, who is here with us.
Anisha, there are some questions?
Yes, there's a question for Stefano.
Yes, please. Okay. But I cannot see the question from here.
Can you read the question? It is
So please sit down. So
yes, but then it means that we have to give the floor to Stefano so that he can answer.
Yes. So,
sorry. So Stefano, there is a question for you that's going to be read, and in order to answer, to click again on share audio and video.
Yes, please. Hey, Sophia, I don't hear you. You are muted. Sorry.
Hi, can you hear me now?
Yes, please.
Okay, so Natalie is asking, how easy is it to apply your solution to other buildings? Because each building is different. So when you're working with a facade, how do you make sure it can be used with a variety of buildings?
Okay, thanks for the question. So the base structure is a timber frame, which is modular on a more or less a 60 centimeter wide system, and so basically it is scalable in height or width quite easily. And then we are, let's say, developing mainly, I would say, a ventilated facade, which again could be easily modulated in different sizes. But of course, the solution could also be thought prefabricated with the finishing. And again, there are not particularly constraints on the size of the modules. What, of course, is the problem behind is the capability, let's say, to design it and keeping flexibility. And that's why we are developing this, I said at the beginning, BIM platform, we call it, with several plugins that allows to, let's say, share with the technology provider and design team at the right time with the right interface all the information to apply, let's say, the solution to different building. We are doing the same kind of demonstration as Maria said, so 3 real buildings, which are a bit different one of the other in terms of sizes, climate, and yeah, typologies of constructions, and also 6 virtual buildings. So we hope that this will allow to, let's say, test also this kind of a flexibility, which of course is an issue. I hope I answered, but in case we can discuss it later, with pleasure.
Thanks, Stefano.
Thank you.
Okay, I mean, what Natalie asked was a very good question, and I think we can dive deeper in the module discussion later on. And I think this is an issue that all of the projects are facing. But I would like to talk to you about another project that was, it's a snare. It started 19-20 months ago at the beginning of 2021, and it will last for 4 years. And it includes a good number of partners and tackles similar issues, the 2 projects that we saw before. The overall goal is to boost the net zero energy building renovation throughout Europe via packages of solutions that include both passive, active, but also very much focus on digital tools. The 2 main pillars that we have in the projects are a modular envelope mesh that you can see on the right hand side of the screen. Basically is a frame that can include different active and passive technologies, and then a set of digital tools anchored by a digital platform that can support the renovation throughout different renovation stages and through a digital toolbox. Tools can be used by users. From the beginning? No.
Yeah, the last sentence.
Oh, okay. Sorry. I'll try to go closer. And so the project is focused on, is anchored on 2 main pillars, and one is mainly focused on the envelope side. So by developing a modular envelope mesh, there is basically a frame that can include different active and passive technologies, and you can see what they are here. But we will also talk about them later in the module, in the following modular session. And we also have a great focus on digital platforms and digital tools that accompany the renovation process across along the different stages and for different purposes and for the benefit of different users. So we have a data acquisition tool, decision support tools, digital twin for the operation phase, and so on. You can see zooming in on, which I already introduced, the mesh, which is this aluminum-based framework that can include, based on prefabricated element, different components. Mainly here we're showing active components, but also insulation module. We are having some issue developing some of these, but the majority are being developed, mainly related to the active generation of energy on site. And then we have a great focus on digital twins and digital tools that, as I mentioned before, can support different things. For the building components, so everything is based on a industrialized prefabricated modular facade panel that is somehow standardized. It has some degree of flexibility. As we also was related to the question before, there is also a challenge with the complex, but for a lot of geometry, it can be applied and it can be customized to the need of the specific application. And then here we can integrate different renewable energy technologies, both for electricity generation, so BIPV, and also hot water via solar thermal. And we're developing a lower TRL PVT technologies that generates both of them. We also had the ambition, but it's in lower TRL and farther behind in the developing journey. Heat pump coupled with the PCM, and then as well as smart windows. And then we, similar to the other projects, we had a great focus on digital platforms. So we are developing a renovation supporting platform that is then subdividing different modules. One of these is the early decision support tool that support in the early design phase of the renovation packages. And also we have a great focus and activities on automation, automated acquisition of data. This can be done from open source of data, but also from from this case, like the picture is showing, from drones and from let's say automatic acquisition of on-site data through robots. And then we have a smart building energy management system that can also couple the information collected in the building information models and convert into an operational building information model, and finally digital twins. When we talk about some of the challenges that we have, of course, when we talk about the digital reality and the physical one, sometimes we have to make sure and we have to deploy strategies to ensure that the two world, that the digital reality is representative of the real one. We want to define synergies and strategies for how to couple different technologies in order to have effective packages, and this is something that we can discuss later in the breakout sessions. And then the last one is assessing the performance of the different technologies and how they can respond to code and to KPIs regulation. Here you can see in the picture some fire resistant testing that we have done. But we're doing a lot of tests in different labs to check different KPIs and performances of the different components. I hope this was clear as well, and like the other ones, and we can discuss much further this morning. I don't know if there are any questions, so we can move on to Power Scheme Plus.
Yes, there are a few questions. We can start with Ensnare.
Right.
So the first one is, are the thermal batteries also integrated into the facade, or are they just attached to it?
So for thermal battery, you mean electrical batteries or the PCM acting as a inertia battery of the building?
I think it refers to the PCM battery.
Yeah. Yeah. Well, thermal storage. it should be integrated into the insulation of the prefabricated element, but it's still under development, so it's still not quite advanced as the other ones, the active solution.
The second question is this solution for residential buildings as well? BEMS and digital twins can be quite expensive, so wondering if it's only suitable for larger commercial buildings.
You can also answer that question.
Yes, what we're trying to prove here is actually that it is suitable for a number of buildings, including residential and commercial buildings. The aim of this project is to make renovation more sustainable, more approachable for the larger types of buildings. So that includes commercial and residential buildings. And what we want to achieve at the end is that even residential buildings can afford this service.
Yeah, these projects, they focus mainly on residential. So, you might see a lot of attention and a lot of keywords focusing on residential, but, the solutions a lot of times have been deployed into the market mainly on commercial buildings, especially these digital tools. So the goal is to apply to both.
May I add something to this very interesting discussion? When you try to implement BIM and digital twins at residential buildings, at this level of research, you're actually solving a lot of technical problems that relate to the implementation of BIM. The creation, for instance, of dedicated IFC files for these prefabricated components is a challenge by itself, because they are not commercial components, they are components, systems, kits that integrate a lot of different components, and it takes a lot of effort to develop the methodology of how you develop the IFC files. Also, the implementation of the BIM for the design and coupling with the prefabricated facade components, it's also something which is not trivial, and I believe it is solved via this research project. So I see an added value, even if it is not cost effective for widespread use at the moment, but we are actually developing new approaches and methodologies in these projects, and in the future they may, which may find marketplace in the future.
Thank you. And now there's a question for Maria.
Well, I think it's a question that relates to all the yes, please go on for the people that.
Okay, so Natalie has asked that there seems, so this is about the previous presentation. This seems like there might be some overlap between Project Infinite and Plural. So how do you ensure that you're not doubling up the work that you do?
It seems that one of the technologies of Infinite or Infinite, depending how you pronounce, it's very similar to one of the technologies of Plural. Technically, they are not exactly the same. They are developed in a different way, but these three projects that we just got the presentations have been, all of them approved under the same call. And the call was very specific in terms of requirements. And this is the reason why we have developed a very close collaboration among the three projects. And although there might be similarities in the approach, in the methodologies, in the technologies that are being developed in the projects, we are collaborating very closely, trying to exchange experience and create added value out of these similarities in the projects. So I don't see it as a threat. In the contrary, I see it as a great opportunity for collaboration. And this has started already since a year ago. And the result of this workshop, this workshop is a result of this collaboration. So it's not a threat. In the contrary, I see it as an add-on, as a win-win situation to have similarities in the technologies among the projects. Okay, so Any other questions? Or?
That's everything.
Okay, thank you very much. The next presentation will be from PowerScale Plus and will be done by George Korke, who is he's remote. So please.
Just one moment for the transition.
Hi, Sophie. Hi, Sophie, can you hear me?
Yes, we can hear you very well. Just a moment. So we
Okay.
mute ourselves and then.
Okay. Can I share my screen?
Will you share? Yes, sure.
Okay. I will try. Can you see?
No.
Okay.
No. You may just open your every windows on the same screen and you share your whole screen.
But we can use our presentation.
Yeah, it's just.
But in case we have a backup presentation for you, in case.
George,
Okay. Okay. Because it has some animation, so I will need for you to click on those. Okay.
We will do so.
Okay. So please go ahead.
So we just mute ourselves. Huh?
Okay. Okay, so good morning, everybody. I'm the coordinator of the PowerSkin Plus. We were funded, this project was funded on the previous call, the energy efficiency call of 1990, the integration of energy smart materials in non-residential buildings. So we will hear a little bit different from the previous projects. Just to tell you that we are 14 partners integrating different types of research entities and companies. Next slide, please. Okay, so the overall concept of PowerSkin proposes the release of the untapped potential of curtain wall facades for the high efficient energy valorization in buildings in a truly integrative smart curtain wall facade solution, specially developed for non-residential buildings, comprising super insulation and energy efficiency elements, combined with solar energy harvesting components, and these energy harvesting components linked to active and passive energy storage features. Next slide, please. So here's a glimpse, schematics of the different types of modules. Some people call it kits, we call it modules of the PowerSkin proposal and concept. And what we are aiming is a truly all combined modular energy management package that can aim for superior energy efficiency and sustainable eco-design standards, specially addressed for, as I told you before, non-residential solutions. Next slide, please. So the key objectives of the project. So we are trying to generate these hybrid-enabled systems with different multifunctional add-ons. We call it add-ons on different features that we are proposing, obviously for NZEB and Plus Energy building curtain wall solutions. And the aim of our project is to demonstrate this holistic facade solution in our operational environment. So we will end on the 4-year projects on a TRL 7, but we are aiming obviously for future commercialization of our different solutions. And we are aiming at new buildings, but also providing the retrofit market with our management systems, our energy efficient management systems. Next slide, please. I will not go too deep on the methodology in terms of the project, but just to tell you that we are tackling a very different number of key enabling technologies, and we are trying to pilot them in an operation program, in a pilot program. So we are talking about super insulation elements, nano-enabled coatings. We are working on active and passive PCM-driven latitude storage elements, and this innovative microfluidic thermal storage system. We are working on solar energy harvesting components based on flexible inkjet perovskite solar cells, either being semi-transparent and opaque, and finalizing with this electrical building management system supported by, we are aiming for second life lithium-ion batteries from used electrical vehicles. Next slide, please. So here I've got a small animation that I will ask Maria to assist me on clicking on it, just to tell you more or less what we are addressing in the different models. So we divided the transparent models and the opaque models. In the transparent model, a more cost-effective, just a second, Maria, don't click already. In a cost-effective standard option, we start with a common triple glazed insulation glass unit, an IGU, that can be harbored either in a modular framing system, being a stick or a unitized system. We are trying to make it simple and more adaptive possible to different types of framing solutions. And in a premium option, we start adding some add-ons, some features, extra features for enhanced performance. So go ahead, Maria. We start with, can you click, Maria? Okay, so we start with functional nano coatings that for this IGU system can be providing properties such as self-cleaning, anti-reflective, photocatalytic properties, wavelength control for the PV's power generation. Next, Maria. We have this innovative add-on that it's based on a capillary glass sheet for active thermal heat storage and diversion. So we use a microfluid inside these very thin channels and we pump this microfluid along the facade in order to remove heat and combine this with a heat pump. Next slide. For the transparent models, we are working with flexible perovskite semi-transparent solar cells for the energy harvesting solution. And we finalized this combining with the electric storage system, which we intend to be an autonomous storage system using this reused batteries. But also we are intending for this system to be also connected to the grid. In our, just to give you some examples of the different prototypes that we've been developing in these 3 years of project. So you can see the IGUs that we are developing. In the middle, you see our prototypes. They are currently being tested of the microfluidic heat storage system. You can see also some semi-transparent PV cells that are being developed by one of our partners. You can see some examples of the different nano coatings being developed for the transparent modules, and also schematics of the building electric management system, the battery system. The opaque model, it starts with the standard solution. Go ahead, Maria. It starts with a simple module that can be composed of skin panels of glass or composite or even metal, and in between a super insulation model that we are working exclusively with vacuum insulated panels, so to give enhanced performance in terms of insulation. Next slide, please. Yes, the premium options, we start adding these add-ons. So again, the functional nano coatings, either to provide UV weatherability, to provide fire resistance to these modules, also to the opaque modules. We have an add-on that it's based on phase change materials, also that is working with a heating foil to make this transition actively. For these models, for this add-on. And also, please, Maria, we have the opaque solution provided by our partner in terms of the flexible perovskite solar cell. And finally, and as the transparent model solution, we also combine this with the same electric battery system. Next slide. Here are some of the examples of our development so far. So you can see some prototypes of our modules, opaque models that can be work as a single opaque facade model, or for instance, as spandrels in between parts of the building, parts of the facade. You can see the PCM with the eating foil, the PCM pouches with the eating foil in the middle. You can see the opaque flexible perovskite solar cell being tested, and some testings regarding fire resistance, and some prototypes of our batteries that are being tested in the project. Next slide, please. So we will have 3 pilots running on quite soon. Actually, we are in the verge of starting this installation in 3 different locations. Here in Coimbra, in Portugal, one in Germany, and the other one in the Czech Republic. It will be 3 different types of buildings in 2 different types of climates. And we will try to prototype in these 3 pilots the different solutions that we are working on the project. So the buildings are very different from each other. So we are trying to demonstrate how adaptable these models are to different types of buildings. Next slide, please. This is an example of the building here at IPN that will harbor some of the modules that we have been developing the project, and this installation will start quite soon in October. Next slide, please. So basically, just to give you a timeline to results. So we are, as I told you, starting to make the installations. We are running some pilot in outdoor test cells in one of our partners' premises in Italy. So we are already monitoring our solutions, and hopefully by the end of 2023, we will have our solutions completely tested and pilot and the full documentation of our developments so far. Next slide, please. So to give you some overview of our key barriers and challenges, many were already addressed. So again, the cost of high performance solutions, it's really a barrier to some of the more R&D solutions that we've been trying to provide to the market. The slow pace of the retrofit action is also some barrier that we are facing, but this is a general barrier of the market. The technical challenge, the development of these multi-price, efficient and safe plug-and-play model solutions, it's not that much easy for market acceptance as we've been knowing, especially for the retrofit market. It's different to work with new buildings and retrofit solutions when you are talking about modularity, but we can try to speak a little bit more about this later on. Obviously, the technical barrier, the highly diverse buildings and facade types make difficult to design these universal and easily adaptable retrofit solutions, as I told you. There are some other challenges also in terms of the standardized solutions capable of fulfilling different requirements in different countries, in different regions, and obviously also some bottlenecks that are still preventing a further industrial uptake of some of these high solutions, high-priced solutions, especially the ones driven from nanomaterials. So just to finalize, my contacts are here. I will be available for any question. And if you want, you can follow us in social media accounts and also in our website. Many thanks for your attention. I cannot hear you.
Right. So thank you very much, George. I don't know if there are any questions. Okay. If not, then we can proceed with the next presentation that will be made by Matthias Falland. He will present the Switch to Save project. which focuses actually on the transparent part of the envelope. And this is very important to have with us because it complements the activities of the prefabricated envelope components. So Matthias, please. The presentation. You have it? Yes, sir.
It's here. Or I think we did like this.
Yeah.
Okay.
Yeah, that's it. Sir.
Okay. Hello, everybody here in the room and in the online audience. I hope you can all hear me. My name is Matthias Fahland. I'm the coordinator of the Switch to Safe project. The exact title is Lightweight Switcher with Smart Solutions for Energy-Saving Large Window and Glass Facades. The project is in the same program as all of the projects actually, which you had already heard. It will last 3 years until mid of next year. Here in this slide, the key objectives of the projects are very shortly summarized. We have the of the building and want to achieve this by paving the way to the integration of smart windows. There are two boundary conditions which we want to keep. One, the solutions should have a low weight in order to make an integration into existing buildings as a retrofit easy to do, easy to accomplish. And secondly, we want to focus on manufacturing routes which allow us to do this retrofit into existing buildings on affordable prices. There are various variations partly in the market, but definitely in research. In the previous talks, we had already sometimes heard this name or this term. In this project, in the Switch to Safe, we are focusing on two different solutions for smart windows. One is the electrochromic window, which is a window or glass sheet which changes its optical properties according to an impulse which is coming either from an automatic control system or simply from a human who is intending to change the properties. And of course, the properties can be changed according to external changes in illumination or in temperature or energy impinging on buildings, internal temperature, and so on. The second version of smart window, which we are pursuing in this project, is a summerchromic window. This is a window which is changing its property in reaction to the window temperature. So there's no external control either by a control system or by a human. The window is simply doing it by itself. And here the point is, of course, that on hot temperatures, we want to have a different property of the window compared to low temperatures. And we want to implement here materials which do this in an appropriate way in order to have always the best situation for the energy efficiency. So this is an overview about the concept and methodology. We have altogether 4 phases in this 3-year project, which is quite challenging from the timeline perspective. We started with some material development. I really want to emphasize some in this case. Of course, these materials had already been in research for a longer time. Nevertheless, for our purposes, it was necessary to do some adaptations. But then the research and the efforts very quickly shifted to developing and optimizing the technology to bring this really into area in order to follow up the objectives which I have shown. We want to make it affordable and want to demonstrate it in reasonable dimensions. In the third step, we integrated these flexible and lightweight pre-components into really building components. We want to build IGUs when we want to prefabricate glass sheets with laminated thermochromic or electrochromic components. And we want to develop these building elements to a stage that it can really use in a plug-and-play manner for building integration. And this brings us to the real final step, which we have also included into Switch to Safe, which is bringing these components into real buildings. We have here two large buildings at different places in Europe. One is quite in the north, in Uppsala, near to Stockholm in Sweden. And the other one is, I would say, almost at the very south of Europe, in Athens, in Greece. So in the first part of the project, as I have already emphasized, we have made some material adaptations and the development of the components. And based on the results that we have achieved there, there had been done various simulations which should give us an idea how big the effect could be in the demo buildings once we have installed everything as it is intended. Here you see the figures which emphasize that you can save energy both in the cold climate by saving heating energy and in the warm climate by mainly by saving energy for air conditioning. And this was done, the graphs which I show here are done on a simulation basis, based on the material properties which we have achieved in the project. The demonstration in the real buildings, that's still an outstanding work package in this project, and of course cannot yet present it here in this conference today. So these are the plug-and-play solutions as we have it. On the left-hand side, the electrochromic window. You see an IGU with in a size of more than 4 meters. This IGU has a roll of thermochromic material implemented, and it's ready for installation, as you see it here in the facilities of one of the project partners. It's more than 4 square meters, which is already a reasonable size for really demonstrating that this is something which can easily be integrated into buildings. On the left-hand side, you see a roll of thermochromic thin film glass. Yeah, as you might already guess, this TRL level of this infusion is a little lower than for the electrochromic. But nevertheless, also in this for this material, we will integrate it into Windows and present your solutions which provide measurement results at the end of the project. These are in order to have a proof of the gain of inefficiency in the buildings. We have really the concept to test in the last year, which is remaining for the project, as many configurations as possible in order to find out what's the best solution. Configurations are in different sense. We combine TC and EC together. We combine them separately, and we make these tests in various environments. You see this office building here in Uppsala in Sweden, which will be equipped very soon with electrochromic version. And you see 2 mock-up buildings which are based in Athens. There will be also a commercial building, a hospital in Athens as well, which will also be equipped with the solutions. And we also still consider to have some mock-ups in Germany, additionally, with the intention really to collect as many data as possible until September next year, which is already pretty close. And this demonstration, what we already have demonstrated, is that within the partners of Switch to Save, we are capable of really showing that we can manufacture this in an efficient way, achieve pretty large components. And this sets us into a situation that we can really bring this to a wide market. And an important part of the dissemination strategy of this project is that in the last phase, which is now going on, we have implemented a design contest, which is open for architectural students. And this design contest is really giving the opportunity to play with components, to see how they can be integrated in new architectural concepts, how the energy efficiency potential of these components can be used in the best possible way. And this design contest is open until next March, and I hope that we can encourage as many architectural students as possible to take part into this competition. And I also need to say we are very open to see these solutions and bring in these ideas for projects. Let me round up with the key challenges or key barriers which we see. Of course, already within the project, but probably also in the time after, we have at the moment problems with manufacturing costs and also with installation costs. I think that's something which everybody sees in daily life. So that's something very common in the present serious situation. Apart from this, I want to emphasize another point, which I, from my experience, meet quite often if it's coming about projects in architectural area. Here, we are very often facing lifetime expectations, which are in many years or even can be counted in decades. That's, of course, always difficult if you develop something new, especially on the material basis, to give such kind of guarantees from the spot. That's nearly impossible. That's why I think it's very important also from the perspective of the European Commission to have such an pilot market in which you can demonstrate new solutions without having these constraints or these requirements with full seriousness. Let's take it like this. With this, I want to end up. I see the next slide is already the next project. If you want to have any information about the project or about details for the design contest, which is open until March next year, then you can contact me or Switch to Save website anytime. Thank you for your attention.
So we stay with the on-site presentations.
Is that a question?
Yes.
Okay.
So it's a question from Natalie. Do these windows also do energy harvesting? And for the electrochromic windows, what kinds of controls would humans or control systems have over windows, which is what action could be controlled? And do you have any problems with these controls with respect to connection to the indoor systems?
First question about energy harvesting, that's not primarily implemented into the project. Both of them are passive systems, not harvesting systems. For the second one, we are actually aiming for an automatic, mainly for an automatic control of the electrochromic system. The chromic is not controlled, that I've already said, but the electrochromic system here is really one of the work packages was how exactly look the properties of the electrochromic window like, and how can these properties be exploited in the best possible way, depending on the external condition. So what you can change in the room is both the illumination, so you can dim it so that less light and also less heat enters the room. Of course, you need to find a balance, because at the end of the day, if you switch on the light inside, then it makes no sense. So the right level is important. And the second thing which you also change is the irradiation of the near-infrared light from the sun, which is only heating up the room. So you can change this portion as well by partly it's reflected to the exterior, partly it's absorbed by the window itself. And here it's the same. You need to decide whether you want to have this heat in, which is more important if it's colder or in the northern latitude, or whether you want to keep it out more or less completely, as it is the case in Greece.
Okay, thank you. Do you have a link for the contest?
Yes, we have, but it was originally there was intended a slide here in the, sorry, for some reason it wasn't.
Sorry for this, I don't know how it happened. Yes, we do have a link, and we will share it.
Okay.
Yeah.
We can share it in the chat.
In the chat. Probably Lenka can share, because Lenka is online and she could share the link for the competition.
Okay. Thank you. I think that's everything from Matthias. And there's one question for Jorge.
Yes. Could you, do you want to repeat the question for
Yes,
Jorge?
sure.
George.
But I need to connect him again.
Okay,
So can
sure.
answer.
Oops, sorry.
So there is a question for
Okay.
George or I don't know how. George. So Anisha, you may read the question, and in parallel, I'm giving the floor to George. Yeah.
Okay. So Susanna says that it's very interesting. And are there any so has LCA
I cannot hear you.
Yes, sorry. Can you repeat the question
Yeah.
from the start?
Thank
no
you.
problem. So Susanna says that it's very interesting. And are there any technologies that you think are the closest to the market? Also, has LCA been performed for these products?
Yes, surely that there are some of our developments are very, very close to the market. Actually, the IGU systems that we are developing, along with some of the nano coating multifunctional add-ons, are already being commercialized. So we are trying to pick up some late developments and early research into new products that can be highly adaptive for the market. We don't want to be that much disruptive in the overall solutions that we are addressing. But yes, some of our developments will stay at the end of the project on TRL7, but there are actually others that will be very quick to the market. We believe in 2-3 years we'll be having this on the market if the market responds positively to our developments. In terms of the LCA, yes, we have a work package running on during the 4 years of the project, and actually we've been making these developments following life cycle analysis guidelines. So we are addressing LCA and also LCCA to our project, and we are also even working on social LCA because we will have real people living in one of our pilot buildings. So we will be able to have some feedback on the level of comfort and how these new elements and new facades will work in real life. So yes, we are engaging LCA in our project. For instance, just to give you an example, we are developing new vacuum insulated panels, and we are working on alternative hybrid core systems driven from renewable materials or from recycled materials. So we are always trying to address sustainability in our developments. I don't know if you could hear me.
Yes. Yes, very well. Thank you.
Okay, okay. Thank you very much.
Thank you.
Yeah.
So it's your turn now.
Yes. Amisha is doing everything. She's
Yeah.
moderating, she's answering, Okay, the next one to present the Step Up project is Amisha Pansal. We are running very late because we thought we had enough time. So I think we will have to close this first session after the presentation of Amisha, and we will continue after the coffee break with the presentation of John of the Drive Zero project and of the positioning paper, which will be remote. So Amisha, please, the floor is yours.
Thank you, Maria. Okay. Hi, everyone. I'm going to give a quick presentation on the Step Up project. So the main objectives of the project are basically to address the main issues with the renovation market in Europe by making it more attractive and reliable, reducing the performance gap, and doing that by showing, by validating the benefit of these technologies by monitoring and verification technologies, optimizing renovation investments by using an iterative approach to financing and doing the renovations, minimizing time on site by using plug and play technologies which are assembled off site and they are modular technologies, and accelerating in the end the renovation market by using an interoperability protocol for these solutions. So having all these technologies is great, but what may be missing sometimes is that interoperability with the existing technologies within the buildings or other kinds of third-party products that you want to include in the buildings. So the concept of Step Up is to address all of these concerns by using data intelligence, a life cycle platform, Step Up plug and play technologies, addressing the third-party market, and using innovative financing to address all of these issues in the renovation market. And it is aimed towards the Europe's renovation market and making it more affordable for all the stakeholders. So the main technology I will be talking about today will be the plug and play facade, and the process that it follows through to till it comes to the site is it starts with the 3D relief and pull-out test, which is conducted by our partners Eurocat and Money Group, and that happens before we go and evaluate the site. And once that is done, the site is evaluated, and all these site-related issues are being taken into account before it goes into production and before it gets transported to the site. So these technologies, this PNP technology is supposed to be modular, and it's a plug-and-play system. One thing that we consider really important is monitoring the performance as it performs to see it's performing as we expect. It is assembled off-site and it's highly customized, and of course it is aimed to improve the energy performance of the buildings. And I'll go on a very high level of what does this plug and play facade consist of. So we have an anchor system on which we have a galvanized steel structure, and this is followed by the sandwich panel, which is made of mineral wool or polyurethane, and the windows are installed after this, and as well as the protection elements and brackets and profiles on which the final facade panel is going to be laid on. There are different module types, and this is, of course, to address the different variety of facades that we may encounter in buildings, and it can adapt to different window sizes where necessary. One thing important when trying to address the renovation market is to be able to be flexible, and the plug-and-play technology tries to do that by having various types of insulation materials, sizes that make it easy to transport, and different external finishings. And another key element that I mentioned before is integrating third-party technology. Here we call it third-party cluster, and this could be passive technologies as well as, technology provider cluster. This could be passive technologies and active and monitoring technologies. So passive could be sun shading equipment or high-performance windows, and active systems could be demand control ventilation or heating and cooling systems and PV systems. However, so far we have only managed to integrate grad hermetic blinds so far. This also addresses the fact that there have been, like all research projects, we have faced a lot of issues due to COVID, and the increase in raw material costs. It has complicated how we approach a number of things in the project. This includes the TPC integration. So this is definitely something we would like to do more in future. The installation sequence is, first of all, we position and install the plug-and-play modules on the existing facade, and this is followed by positioning of jolly modules and the fixing of the jolly modules to complete the facade. I will show a video to show the installation. Let's work.
Just a moment. Perhaps we just have to enable content.
Oh, right.
Oh, it works or not?
It is on YouTube, I think.
Ah, okay. It's not integrated in the PPT. Okay. Okay. So I think it's okay. Ah, no, but okay. Just 1 minute.
No problem.
Okay, so here is the slide, so sorry for this. Where is it? Is it in the window?
Happy.
Close the eruption. Just 1 second. To be able to see this video. Where is it open? It's here. Okay. Yes.
We can see now.
Yes, I think so.
Okay, thank you. Right. Yeah, it still works.
It's okay?
Yeah, I think so. Can you see that?
Yes.
Okay, thank you. Okay, so you can see here an existing building, and firstly the anchor system will be installed on which everything else goes. I'll make this fast forward just because I'm aware we are low on time. Yes, and then we have the pre-assembled facades being shipped. The sizes of these facades are being adapted so that they are easy to install, easy to transport to different sites. And this is the mineral wool insulation. I didn't remember music. Yeah. Okay. Thank you. Let you. Thank you. And yes, that was a quick video of the installation sequence. So to summarize, the key barriers that we're facing, like I mentioned before, is similar to all of the research projects right now. We are experiencing an increase in the cost of materials, and this is also exacerbated by the fact that because this technology is quite new, there is some hesitation from installers and contractors of how to approach this. Which is expected, and we believe that if we install this in a real case pilot, it definitely will help in that validation, as well as being able to monitor the energy performance from before installation, after installation, and continued performance monitoring. This is something that will also validate these key barriers. And another issue that we have faced is we are not able to integrate as many third-party products so far, but we are aiming to do that as we go along. So thank you very much. That was a quick summary. Please let me know if you have any questions. We also have representatives from Eurocat and Mani Group who can answer more technical questions. Yeah.
I see no question in the chat.
Okay.
And I suggest you have a coffee break. Yes.
Okay, perfect.
So if there is no question,
okay. Thank you.
coffee break.
To the online listeners, we're going to have a coffee break and we'll be back at 10:45. Thank you very much for the interactive. Huh?
Yeah. So welcome back, everybody, after the coffee break. I'm happy to present the Drive Zero project among all these very interesting deep innovation projects. Nice to see them all together in one workshop. Also, yeah, I'm representing a big consortium. And yeah, the project started already in 2019, so we have 1 year to go, ending in September 2023. I can go to the next slide. Well, the aim of the Drive Zero project, as all projects, is contribute to the decarbonization of the EU building stock. But what we maybe do different is that we do not have a top-down approach of developing technologies and offering them to the market. We start from bottom up, working together with the consumer. And as a second approach, we not only want to contribute also to an energy efficient building stock, but also to a circular building stock. So we are combining both transitions. So coming up with circular deep innovation technologies. So as in most projects, we are developing plug and play prefab deep innovation solutions, consumer centered with attractive and understandable information of real total performances, which we also like to showcase in our demonstrator projects. What we are particularly looking for is to which local drivers we can connect. So, for example, there is a region in the Netherlands, for example, which have severe problems with trimmers of mining gas from the soil, and well, improving these houses. Why not do it in a circular and energy efficient way? So this, for this kind of local drivers, we are looking. So that's, we think that this is really pushing the deep renovation of the housing stock. In that sense, that becoming green in itself is in most cases not a very good driver to convince people to adopt deep renovation solutions. Yes, yeah, this is what we are. This is actually representing this. On the left side, you see housing just before the renovation, and on the right side, you see housing after the renovation. And if you hit the button one more time, Maria, please. And what we see here is that these kind of wait here, please. Is that these kind of renovations are quite material intensive. So this also has really severe implications for the environment, a large ecological footprint. And also, what we see on the banner on below, it's an example from the Netherlands. One of the housings in this block was net zero renovated, but the neighbors were not very pleasant with that. So they faced a lot of disturbance during the deep renovation. There was also the property was damaged. It was poorly communicated. They are complaining about the poor aesthetics of the entire building block after the renovation. So this is not what we see as a user-centered approach, because also the neighbors here are stakeholders in the project. So if we metaphorically, is this the way ahead to renovate the building stock? Well, in the Drive Zero project, we don't think that is the way to go, and that we could do this better. So this is what we really drives our. It's in the name. What's driving our developments. Next slide, please, Mariam. Okay, so our approach, it's not that it's ordered 1, 2, 3, 4, but it's really complementary. So we are developing technologies, plug and play deep innovation solutions, but they are at least circular. So that's the technological development part, but it's complemented with really consumer-centered approaches, and also involving and informing occupants about the performances of after the deep innovation. Yes. Okay. Well, in our consortium, we have you can hit a couple of times now, Maria, and you see some of our partners. So what we wait here, please, Maria. So we have really experienced technology developers who are already in the market, offering technologies, modular plug and play technologies, and now we're trying to aim to make them more circular, consumer oriented, and also fit in holistic deep innovation concepts. Well, this is an example of what we have developed, and before we go to the demonstrator project, we also work with test beds. So you can here see an example from the Netherlands, on which I might work myself, is that we develop various facade modules which differentiate in the level of circularity. In our approach, the most circular solution, what we did is we harvested materials from demolition sites, and we used the materials to renovate nearby housing units. So this is what we are trying to do. Besides that, we developed plug-and-play 2D facade modules. We are also developing some other technologies to come to a holistic renovation kit. In that sense, we have also developed prefabricated 3D extensions, also with the circularity principles. What we also offer is compact building surfaces kits. They can be put on the roof or in front of or in the back of the property. And they need to be integrated also in a circular way. So it's also important to look at the interfaces. So also we are working on that in our projects. Next slide, please, Maria. What I want to showcase here is that it's not only important to you can hit the button not one more time, Maria. Is that we're not only develop the technologies, but it's also so necessary to develop the complementary processes and supply chain setup and business models. So we have a set of complementary innovations supporting the uptake of the technologies which are of course at key in our project. Next slide, please. It's already my final slide, so I really try to be brief. Of course, we are a little bit behind time. So some of our key barriers we are facing is some legal and regulatory barriers, but also lack of trust and interest in deep innovation technologies. So for that, it's really important to have this user-centered approach and also look at local drivers to really make this transition occurring. And of course, some challenges. We have some financial, legal, and operational risk we need to cover. For that, also we need those the complementary innovations I was referring to. And well, the last challenge, and this is typically to our project. I believe it's occurring in all the projects we have seen in the last hour. Is that when we started, the market prices of virgin materials was quite low, but of actually all the virgin materials, also the gas and oil. But this has changed in the last couple of months. So this challenge is really not really bothering us at this point. Well, some of these the barriers we faced was also input for the workshop we did during the Sustainable Places Conference last year. So we had an interesting workshop with 6 deep innovation projects, and this resulted in a positioning paper, which I will discuss later on in our workshop. So this was it for now, Maria.
Thank you very much, John. Thank you very much for the interesting presentation and also for introducing actually our next topic. We have concluded the first part of this workshop with the project presentations. Now we will move on to the first roundtable discussion with the title Mapping and Clustering of Technologies Developed in the Projects. The roundtable discussion is split in 2 parts. The first part is a short presentation by John on positioning paper that was developed as a result of last year's Sustainable Places workshop. And I would like to invite Federico, who is here with us, to moderate the panel discussion. Sophie is going to ask all the partners that are online will give access to all the partners.
Yes, you can.
Oh, there's a question. Okay, so Sophie, probably you could say.
Yeah, sure. So please, all online speakers that are participating in the first roundtable, please ask to share your audio and video. So we have already John, George?
Federico is here, and of course Matthias is here with us, and they're going to sit here on this side, and people will be
so online only John and George.
George online, and of course any other of the workshop participants is free to ask questions and explain their ideas and positions. So I will invite Federico and Matthias to come on this side to moderate the workshop.
So you're still sharing the
Yes, we need, well, the positioning paper will be presented by John, and then Federico is going to present very shortly what we have done as preparatory actions for the roundtable discussion, and then we will have the discussion. This is the plan.
Okay.
Okay, thank you. Will you be able to change the slides of phone, or should I do it? Do you want to see the letter?
Yeah.
Yes.
Yeah, and actually, it's,
Okay.
you know, also other ones might be interested in speaking in addition to the moderators.
But can we have access to all the people?
So all online participants that wish to participate directly in the roundtable, if there are not too many people, it is feasible. You just need to ask to share your audio and video, and I will enable you. And in case there are too many people speaking at the same time, well, it might be difficult. In this case, I will enable you, but you can still use the chat. And please, when you don't speak, please mute yourself to make it feasible. So should I accept Marta, Stefan?
Yeah. Everybody that wants.
So I'm accepting everybody that is requesting to share audio and video, but please just mute yourself when you don't speak.
Okay. So now we go on with the presentation of the positioning paper. Okay. So, oops. John, can you hear us?
I can hear you very clearly.
Okay, so please go on.
Yeah, thank you. Thank you again. Well, the positioning paper. What's the what's the background of this? Why did we do? Why did we actually do this in the first place? Well, during the work in the Drive Zero project, we faced some barriers and challenges we could not solve in our project at our own. So they were macroeconomic or even institutional, and yeah, we were quite curious: is this only us experiencing this, or is this has a broader is there a broader presence of the barriers and challenges? So we were quite curious how this how other projects cope with this. So because of this curiosity, we initiated a workshop last year, and now after the workshop, we decided to come up with a kind of positioning paper, which yeah, discusses all the barriers and challenges we identified during that workshop. So okay, no, not too fast. Too fast. One slide up, please.
Oops, sorry. Okay.
Yes. Well, we use a more for all deep renovation solutions developed in the project. We use a more holistic definition of zero energy renovation kits, which are actually also this indication also found in various EU policy documents. But zero renovation kits are actually defined as integrated solutions, which include various technologies, with the aim to arrive at net zero energy consuming buildings. And what is typically of all of these technologies integrated in the deep renovation kits is that they are characterized by a one-to-one mapping between functions and physical subsystems. And for example, so if you want to, for example, reduce energy loss through the facade, well, then you can install, for example, facade panels to perform this task. So that's how we defined energy renovation kits. And if you please go to the next slide. So what we experienced in general, it's already in debate for a decade, I believe now. It's so there are so many innovations, but they are really poorly adopted. And now, what are these challenges and barriers which we need to overcome to increase these adoption rates at a larger scale? So for that, we are interested in the technical, market-based, financial, legal, and institutional barriers which really hinder this uptake of modular and industrial energy renovation kits. And we don't want to stop there. We also want to think about now what are the strategies to overcome these challenges and barriers. So how did we do that? If we go to the next slides, you're briefly discussing the methodology we used. So we invited 6 EU projects, and we invited some key of stakeholders participating in this project. We developed workshops, and we applied a Miro board, an online whiteboard, so to say, to collect all the input for the barriers and strategies to overcome this these barriers. So that's what we actually basically have been doing last year during the workshop. A very interactive session, very intense, and also with very nice and interesting insights. So what were the key results? Well, you can go to the next slide because I want to keep this presentation brief, but this is the end result. We have developed various frameworks to collect all these barriers and strategies, and also to order them in time. And for that, I really invite you to also have a look at the positioning paper, which will become officially available very shortly after this session. But we developed a coherent model. Presented now on screen. I see that it's not in presentation mode, my presentation, so it's maybe not very good to read it very clearly now, because it is a screen within a screen. But what we did in the blue column, we ordered all the barriers and challenges we identified. Yes, okay, that's a little bit better. Could be even a little bit more better even. And we categorized them. So and also on what you can see on the screen is that we collected to that all the intervention strategies we identified to overcome the barriers found. And as you can see, and also as you can expect, is that sometimes you have one intervention which can solve several barriers, but sometimes it's the opposite. Sometimes you need various interventions to overcome just one barrier. So now, just to go a little bit deeper in that, but not given too much detail, one of the key barriers are institutional lock-in. So there are some regulatory issues which we need to overcome before some of the technologies can be adopted to deep innovation projects. At the same time, we have also a couple of project context limitations, so that make it very hard to implement the deep innovation solutions we are developing in our projects. And if you turn please to the next slide, which is the second part of the model, of course, cost barriers, this will always be an issue. How make the technologies affordable? And this, I think, in all our projects, this is one of the key issues to resolve. There are also, and this was, of course, this was one of the key lessons learned from our project, is also how to cope with liability issues. You are offering new innovative solutions and how to build trust. So how you can cope with these liability issues is also something you need to think about before you also can go to the market. It's also about building trust. And it's what also is because it is new, it's innovative. you also have to think about the readiness of the technology. And so there we identified various technology readiness barriers. And of course, in time, this will be resolved, but you can really steer on that. And linked to that, of course, there are some skills and knowledge because it's relatively new. You need to train new skills. You have to share knowledge about how to operate these technologies before, yeah, they will be really fruitful in arriving at a circular and also energy efficient built environment. So this was actually one of this is actually the model we developed in the after the workshop. Well, I'm coming to the end of my presentation. Go to the next slide. One of the key issues actually is that after going through all the barriers and also the strategies to overcome these barriers, when we have a look at the overarching model we developed, we found out it is also really depending on not only developing the technology itself, the products. It's here on the left side, but also you really need to think about complementary innovations, often not technology driven, but about processes, design processes, but also the production, installation, that kind of processes. You need to have these complementary developed with the technologies in order to be to really make a chance that your product will be adopted in deep innovation projects. At the same time, if you do that, this also have implications for the supply chain setup and the way you collaborate in really applying the deep innovation in projects. So this is one of our really key findings and also implications we like to share after this workshop. I was very brief. I really invite you to go over the positioning paper, and for now I think this is a good start for further discussion. Thank you.
Thank you very much, John. I don't know whether there are any questions from the audience. If not, we will. Any questions? No. Okay, so let's move on to the core of the first round table. Federico has prepared a very short presentation overviewing the background work that has been done as part of the preparation of the discussion. Would you like to say something, to present a little bit what it is in here? So, please go. Okay. I don't know, is it okay for you now? Stefano?
Yeah. So as all the participating projects know, I've asked them to complete this matrix where we try to map and to characterize the technologies that each of the project is developing. There are some similarities as we discussed also previously. Maybe very briefly, each project can describe into like in 1 minute what each of the technology is, and then we can start brainstorming about how potential synergies or collaboration opportunities between the technologies resulting from the different projects can be imagined. This first slide is actually cut off, so maybe I leave presentation mode because just a second, because otherwise the power skin technologies will not be shown because it's actually longer. I couldn't fit it in. But I will start. So, the main technology that we are developing, as I mentioned earlier, for the facade is this modular prefabricated plug and play facade that can integrate different things. So, active solution, different kinds of renewable energy sources. For passive, we have insulation with phase changing material. And and as I mentioned before, it's based on aluminum framework. The focus is on residential, but it does not preclude to apply it to other typologies. It doesn't have a specific climate, although it doesn't have a lot of thermal mass because it's aluminum based. And then you know, we are already with this product. When I fill in this table, I already cluster with different technologies because you know the modular facade also includes all the renewable energy sources that we can have. As a benefit is, you know, the quick installation. You don't need the scaffolding. You have easy access of technologies that are integrated into the modular system for maintenance or repair. As the challenges, as I mentioned also earlier, for complex geometries, you know, you have some customization opportunities, but it's you know, if you have a curved surfaces or curved envelopes, it's not so easy. You have additional weight on the facade, and then you have to make sure that the elements are being maintained by the maintenance staff. The facade per se is not being controlled and automated, although some of the elements that are included are. Okay. Maybe we can do the same thing for each of the different projects very quickly.
How we can group all these technologies together. What could be the we can use? I think that this table is very useful,
Right.
Because it's the first time that we managed to bring together all the technical abilities that are done in the project. The question is it possible to group them, cluster them? And this is where I would like to get the feedback of all the audience. Do you believe that there are common criteria that could be used on a technical level to cluster this technology?
Maria, I'm not sure that people will hear you because the mic is here, so perhaps Federico, if you may just repeat the question. Or Maria, if you can come here to make sure that people can hear you.
I was trying to connect to the solar. But my pocket was very good. First of all, thank you very much. I was saying that it is the first time that we managed to collect the technical information about the developments that are done under each project, and I find this table very useful. I think that due to time limitations, it will be not advisable to go through each of the projects. On behalf of everybody that has contributed, I would like to thank them for the very fast response. And the thing that I think we should discuss now is based on the input received and the titles that you see on the top, on the horizontal level, to discuss whether it is possible to cluster, put together common criteria for creating groups of these technologies. For instance, on the active and passive, can we list what are the active technologies that are good candidates for this kind of prefabrication? What are the passive technologies that are the best candidates for this kind of prefabrication? I'm just brainstorming at the moment, the way I see it. Maybe you are seeing it from a different way. Another approach would be, for instance, external, internal, other categorization. This is the question that I'm setting. Or if
the synergies had already mentioned a couple of times, and you especially mentioned synergies which to say. I had already seen in the first part of the workshop that several times in several solutions there has been remarks about smart windows integrated. So it would be, for our project, I think, a great thing for, not for me as a coordinator, but for the partners who are actually doing this, to really get connected with partners from other projects, which can also make an IGU, for instance, or a pane or whatever, with such a material. And another thing is for me quite important to learn. In Switch to Safe, I would say almost in any of the projects, we have claimed costs and manufacturing change areas. We have CPAs, and it would be important to know, it may be even not today, but in the further course of the project, who can do the best, who could realize the best way to really put prefabricated pieces on the floor so that somebody could bring this in. Maybe another project had also good ideas with components, but with prefabrication and realization phase was not ideal for whatever reason. To bring this together so that these projects which have solved this in the best way can pick up also solutions from the other to widen the network beyond the project boundaries. That would be, I think, a benefit. That's a very general view. Of course, as a coordinator, I cannot go into technical details, but if you bring together obviously do this actually, that could be of good value.
I think in the Step Up project, we had a good example of how this could be industrialized. My opinion is that at the moment, this value chain is not yet developed. We have companies that are producing, for instance, passive opaque prefabricated systems. They have the logistics, they have the know-how of how to install them on site, but in their manufacturing process, they do not have the know-how how to integrate, for instance, the transparent parts in their manufacturing, whether it is of value to integrate it off-site, especially for the transparent part, or on-site. What are the limitations in the transportation, in the logistics of transporting transparent and opaque at the same time, pre-integrated? And of course, then the business model is missing, because the companies that produce prefabricated opaque systems, this is their know-how. There are other companies that are producing IGUs, and this is their know-how. At the moment, there is not the interlinking and integrating model. So I think there is still room there to develop further the value chain and the business model. So coming back to the transparent components, if I could summarize what we saw in the presentations of the projects today, I believe, and please add or extend what I'm saying, most of the projects are looking at so-called smart windows. You can hear me?
Yeah, no, it's okay.
Smart windows which integrate either mechanical ventilation or some harvesting features. One of the projects is looking at IGUs, but not as advanced as the ones that are looked at in the Switch to Safe projects. And my feeling is that in terms of the transparent components, the integrated assessment of the performance, it is not yet done. So if you have a prefabricated component that includes a dynamic performing transparent component, like an IGB, for instance, with electrochromic and thermochromic layers, and you have an opaque component that integrates active systems. This integrated performance assessment is what we have done, plus everything else that we have looked at. So taking into account that the transparent part of the envelope is the one that leads to major leakages, thermal leakages and energy leakages, I think this is a key topic for classifying and classifying this type of technology. So the integration of the transparent and the opaque components and their assessment, and how the transparent components can go one step further.
Hi, Maria. Just to give an add-on.
Yes, please.
This is George. I think that where I'm hearing some feedback, but I will go anyway. I think where we can best interact between partners, and if we really want to create impact on getting our developments into the market as easy as possible and really create an impact in social, in the real life, is to probably find some common adaptable integration of the different solutions, of the different modules, of the different technologies that we are developing. Each single product is working only with an integrator, with only one type of companies providing a very, very particular system of integrating this, so all these solutions into, for instance, into a facade, it will still be a niche. We need to find common integration systems for our developments in order for a mass deployment of our technologies. I think that this is the most important, because most of us are working in very similar areas, in very similar technologies, but if we just keep on working on particular integration systems, we will end up on those integration systems solely. So if we want to create impact, I think that this is a key. And also, and just to finalize, we really need to keep different levels of complexity. I think that the approach of a basic models and then getting different levels of multifunctional systems is the key. Also, thinking on, for instance, design for disassembling and repair. If we can keep this simple, because, for instance, Matthias told before about the service life that are expected for these systems, and most you can end up in a model with different service life expectancies for different systems in the same module. How do you tackle this? So we need to keep it simple, and we need to think on design for disassembling and repair of these systems in order to provide the best extended service life for those. So I think that these are probably what I think the key aspects on how to cluster our developments now. Many thanks, sorry for delaying.
Okay. Would you like to say something?
Yeah, I would add something. For me, it strikes the question how we can be interested in integrator from the economic point of view. Most of the projects, and I think all of them have some demonstrators which are real buildings, but they are unique buildings. And I know from the Switch to Safe project that in order to build the IGUs, we had to exchange very specific measures and make this fully accustomed to this special building. It would, for my feeling, a big benefit to have an area where a certain type of buildings is repeated a couple of times. So in my part of Germany, for instance, there's a certain type of schools which all look the same way. And meanwhile, they are all renovated, or they are more than 40 years old. But anyway, there was a type of building. If you have such a school, and you have some facade element, then you have 1,000 other schools, you can apply the same. And even if this is not a part of the project, and a potential integrator to bring ITUs and facade elements together, we had another level of interest into this project because we see the business case. That's, I think, an add-on to the situation that I have a unique building and I exactly know the next building will be completely different.
So actually, if I understand well, what you are saying is that from the economic point of view and from the business point of view, this type of integrated prefabricated solution, whether transparent or opaque open pipe, have an interest only for large complexes and for repeated characteristics of buildings.
Maybe in the next stage, I would say in the next stage. Maybe that's not the final destination. Once people have, especially in this integration step, some experience and some understanding on how complex a change of size or shape or whatever is, then maybe it will be different at a certain point. But for a first or a next step, it would be a benefit to have a kind of renovation where these adaptations are as small as possible.
Thank you very much.
But to go back to what Jorge was saying before, to have some requirements or standardization or integration, so we can try to integrate technologies from one project that were designed to fit into a framework, because we're all developing some kind of a modular framework at the end. But so at the end, we are designing our solutions to integrate into our mesh or framework, but they don't necessarily are able to be integrated into the mesh of another project. So I think, in one way, from a business model point of view, it's easier if you always have the same package that you replicate for economy of scale, but it also limits you on the interaction between technologies and applications. So if at the same time you can have some standardized integration, or at least features that you can control, that helps on tackling the needs of each specific building. Maybe it doesn't apply when the needs of the building are exactly the same, like in the equivalent similar building technology.
I also have a suggestion, if I may. What I was also thinking of some of the discussion, following up what we're discussing right now, and is also that it would also be interesting if we could cross-reference this table, which we have developed for this workshop, with the results of the workshop last year. Because some of the issues you mentioned, I really recognize the barriers we have found last year. This is also a way to cluster and to see how these things can come together, and also what we need to solve for a larger uptake. And also, what's also interesting is that that's also something we are discussing in the Drive Zero project, and I think you all do that in your project. Is also in some cases. Technologies are developed for a specific market, specific country. So, in what way does the solutions we are developing, the technology we are developing, in what way should they be adjusted, for example, to be applicable in other countries across Europe? Or are there maybe specific reasons which technology are not simply not applying? For example, because they have totally different climate zones. For example, we have these building service kits with HVAC technology and all kinds, also PV connected to it. But, as they are developed now, they are really typical for the Dutch climate zone, the Dutch housing typology. So they cannot really one-to-one adopt, for example, in Germany or whatever other country in Europe. So it is also very interesting for us to know how we need to adjust these kind of technologies for wider application through Europe. I think this is one of the limitations in across all the Horizon projects. There it's really niche market development. So if we have a really EU orientation and need to renovate or improve the energy efficiency of 250 million housing units, then there is a challenge there. So for that reason, my suggestion is to see if we can cross-reference this table with the results of last year workshop.
Yeah, that's a concrete. That's a very good plan, and it's a concrete action. I think the climate is probably one of the driving factors for all the technologies, right? Or at least how we try to cluster, how we try to combine technologies to answer the climate external. But probably also building typologies or how the building are being used.
Thank you. I think we have to move on to the next topic of our roundtable discussion, which has to do with the KPIs that we could develop and what we, as a vision, what we have as a result of this effort of bringing together the projects and identifying common technologies and common problems among projects. So Stefano has prepared a short presentation, which I think, Stefano, could you please make an introduction on the...
Yes.
Go back. I'm
Do you hear me?
going to share the Google Docs link with everyone.
Yeah, I don't see anyone.
Okay. And the other thing is Stefano had a few suggestions.
Why didn't you? You could have said that. Okay, so could you, Anisha, could you please repeat the suggestions of Stefano?
Speak louder, please.
And do you want to come over
Stefano, do you want to say what you tried to say before?
Yes, yeah. Okay.
On the
Yeah,
chat?
but it was just I let you talk, and in case I would have added at the end. So actually, what I suggested some clustering criteria based on the table of collected through Federico structure, and I mean I think it could be also some next steps. So trying to see the technology scale, so it is more a component or this is more a system, and I think this opens a lot then possible other clustering criteria. Another could be the level of integration that it's possible, how far the integration can come really during offsite or then finally is on-site, or like before installation. So there could be also, there are some interesting criteria used that could be thought to cluster technologies. And then finally at system level, and then actually this also I think link the first part of the workshop to the second, it could be interesting to to discuss together if we can elaborate a kind of data sheet, like a standardized data sheet for such a prefabricated system for the renovation, that would really then also go in the direction of that Jorge was suggesting. So really, I also believe we have the chance to be together to create an impact with this such kind of solutions, and that's really probably having like common way to see the technologies. Then it's also a common way to see the power basically and the impact that technology can create. So that was my comment, and actually if you agree I can link this directly to the part 2 of the workshop. So I can try to share my screen given that I'm already
We will share the presentation from here.
okay.
Maybe
Do it, please.
Stefano,
Yeah,
while we get ready, can I say one thing just very quickly? In the Google Drive, in the Google file that we use to prepare the table that you all fill out, at the very bottom there is a section with outcomes or something like that. If you can add your suggestion or your idea for how or for the next step, that would be great. I will also try to summarize later, but if you can do it now while the ideas are still fresh, it's great. Thanks.
Oh, thank you, thank you. But I think really it's a unique work finally. So Federico, I'm sure you can we can work together on this. And as you see in the slide shared, the second part of the workshop has the ambition to link the technologies that we are discussing, that we all have presented, to basically the performance, I would say, intended as the final impact, the final aim that probably every calls, every project had from the commission, meaning to reach an energy target and plural and near infinite, particularly as this NZEB, nearly NZEB target for renovated building, and so yeah, while organizing the workshop, we thought that we could try now to discuss briefly on which kind of performance can we really achieve, maybe the project that are more mature. How have you evaluated the performance of your solutions, aiming in this framework of NZEB, or at least pushing, let's say, energy efficiency? And so in the next slide, if you move down, we have tried to propose you basically the outcome. So we could really come out, probably not today, but in also through kind of offline work, to a list of possible KPIs, and then also the methodology to calculate then, to see how far this could be really applicable for the technology that we presented. So I think today we could just start to brainstorm, as also Maria was saying, how far this is possible. Here, I just wanted to aspire us in a very, let's say, open way on possible way to represent finally, that our technologies in a performance, from a performance point of view. I think we all know very well this graph of supply and demand, let's say, metrics that could be primary energy, could be CO2 equivalent or whatever, and we could try to then put some points, understand how to evaluate that of our technologies, how they contribute to move the overall building performance in this kind of graph. Another idea that I've seen in literature, if you go to next slide, and please also hide the yes, please, thanks. It's acting at building level with reference buildings, so it could be working with building archetypes and have every project assessing their technology on a common archetypes. And then next slide again. Is yes, just a table-based visualization, meaning that here this is already a work on NZEB solution set. You see here the reference. So on the rows, there are basically clusterization of technologies. So it could be like, now I don't remember by heart, but it should be like, like insulation or energy generation through heat pump or smart windows, and so this is rows. And on the columns you see building typologies. So where is this applicable, you can tick it, and where not, you let it empty. And I was also suggesting that we might use colors in case to explain also the kind of impact in terms of overall NZEB balance. Next slide is another more, let's say, specific. No, so always table-wise representation. Okay, let's move to the other two typologies of possible, let's say, visual representation is just very much technology related. So probably this applies, for example, just to the smart window component scale that we could try to group, as actually in this paper is reported, like visible transmittance against G value, and mapping, how different technologies could perform in that. And the same is for the last inspiring graph. In the next slide is about cost and efficiency of photovoltaics. So just to close, shall we now have probably, I don't know, 10, 15 minutes, I don't know, Maria, just brainstorming on the following questions that I reported in the last slide. So in your project, how do you evaluate your solution impact in this NZEB vision? Which KPIs and at which scale? So it's more like component scales, I guess, for smart glazing, and or at building scale, which KPIs and which methodology? And of course, I think some projects are already advanced or close to the closure, so they might really, if they want, share their methodology and see how far this is already applicable, or maybe offline we could try to standardize that against in a datasheet way or in table way or in a graph way, just to really have these goals. So that is the challenge, and I let you actually to start the discussion. I hope that was clear.
Thank you very much, indeed, Stefano. You presented very clearly the vision that we have as a result of this workshop. We will continue to work after the end of the workshop, and we will enhance the interaction with the rest of with all the projects in order to try to achieve the goals. Now, the questions are very clear. I think the first question is, how do you evaluate the impact of your technological developments in reaching the NZEB status, if I understand well? So, who would like to comment from the audience here or from the online participants?
I found this table quite interesting, in which you have clusters different types of solutions, and then, honestly speaking, the other coordinate, maybe it was a little bit project specific. But if we could extend this table to all the projects, that would give a really great overview also on a visual basis. So I would really tackle this one. And as we have heard today already, the projects had been followed up with various solutions, and I'm pretty sure that every project manager or project participant has a kind of feeling how what's the TRL level in reality, what's the fulfillment of the objectives which have been set in the project, how well he feels with the result. And this could be mirrored with kind of color in this table, so that you really have a quick overview about solutions which are excellent or a high TRL level. That would also somehow help to boost the interaction between departments.
That's a good one. Thank you. Misha, would you like to please?
Just wanted to add that from my perspective, yes, I think that this harmonization of KPIs and the way that we can try to benchmark the different technologies, KPIs, definition, it's a very good opportunity, Stefano. So I think that we should try to build up this metrics as you did, this table, and try to harmonize the different KPIs from the different projects in order to have a full overview of the broad developments that we are addressing. So I'm all in favor of participating on this harmonization and inputs.
But so at the end, sorry, you know, at the end, this KPI should be both at the system or process level, high level, let's say, I know installation cost, installation time, or overall energy performance, but maybe the challenge would be specifically at the component level, you know, because then we go into each of the components that we're developing in the different projects, and you know, the range of KPIs can become quite extensive. So I mean, it would be interesting to try to harmonize a little bit. Considering they were mainly working on quite similar technologies or approaches.
In the plural project, we have developed a list of KPIs, but there are about 60 KPIs in total, addressing technical, economic, environmental, and social aspects, including comfort and acceptance by the end users. The idea of the plural project is to use these KPIs to classify the technologies to support decision making. Our deliverable is public, and we can share it with you. And this, I think this could be a basis for further discussion. The KPIs range, as you can understand, we have from URU's primary energy consumption to more complicated ones, and they go from component system building level. So we have the classification, and it's quite challenging.
Additionally, we are going to develop a large database of components level, which all the components are classified according to their characteristics and according to their values and according to their technical data. So KPIs will be extracted very easily from there and will be categorized and clusterized in each category without a problem. It's also open and open source, but I think it's open.
Well, the database is not open, but we can discuss. Well, actually, we have two things. One is the property information and the technical information about materials that are commonly used and component level that are used in prefabrication. On the other hand, we have the KPIs, the formulae that are needed to calculate them, and the methodology for calculating them. I'm sure that in other projects we do similar work. In our case, it's public information and could be shared as a starting point for this KPIs. Obviously, it's open to discussion and it can be modified, extended. And I don't know if other projects have done similar work.
Yeah, in step up, we are evaluating building level KPIs. However, we are monitoring performance of the technology as well. So I think there is at a certain level, stakeholders come into play. So what do they want to see? How do they want to tackle that NZEB journey? So are they planning on going into detail and seeing the performance of each technology and how they are contributing to NZEB, or they just want to see the high-level view of how it has progressed? So we have individual KPIs like seeing the performance before and after renovation, and how well the model is calibrated, and what's the performance gap, things like that.
And maybe one last piece. I mean, all these exercises done was great. At the end, I would like maybe to add. I don't know if this existing KPI from Plural already did that, but hide to the smart rating that have been used to to check for building interaction and how the building can be controlled. I mean, at least so far the discussion, especially this morning, has been mainly on passive or the product and not much on how you control them, which is more on the. There was also another project which is Smart Building U, I think, that try to harmonize a little bit that. So if you want to try to do it as an action item to work on, with the stuff from the Plural database and list, and integrate this with this other one more on control if they were not already integrated in your list.
Yes, true. they are not, and we would be very good to do so. But this discussion brings me to thinking that we have a long way to go. And what we started today is the very first step. I believe that we should continue this collaboration. The Sustainable Places Conference gave us the umbrella and the framework for doing this first step of collaborative work. But I would like to propose to continue this collaboration. There are a lot of topics that can be discussed and were not touched today. One of the topics is the control, the supervisory energy monitoring systems, the BIM issues, the architectural aspects that we have not touched upon before, the combination of the smartness of the transparent on the components, and of course what you just said, the SRI level and how we can go further. So my suggestion would be to continue this effort in the future. We will build upon the previous experience of the last Sustainable Places Prefabricated Systems workshop and the positioning paper. And we will try to create a more expanded list of technologies, classifying them according to the examples that were shown in the presentation of Stefano, circulated among all of us. And we propose to have probably the month's time or so catch up and future planning meeting. We are all active projects, and I think within the frame of the dissemination activities of the project, we can plan to organize a common workshop similar to the one that we had today, with more specific topics. So just to summarize, we have to share the link for the switch to safe architectural competition. It is done, okay. So everybody can get it. We have to share the link for the Google document, so that everybody can have a look at the table with the technologies that are developed in the projects. I hope there are not API issues in this table, because what we see as technologies in this table, projects are also exploitable results, but they're listed in a very generic way. Based on this, we will cross-check with and the discussion points that we had during the workshop. We will cross-check with the position in paper with the support of John. We will then, from the plural, we will share with everybody, the participants of this workshop, the public deliverables that relate to the KPIs, and if your AMS group was responsible for the development of the material and component database, issues to share with everybody. We will share this with you as well. And then, having reached this stage and having looked at all these documents, it will be time, I think, to have our next meeting to discuss and decide how we could go one step further with the vision of reaching tables and figures like the ones that were shown by Stefano in his presentation. I don't know if someone else wants to add something on this. As
just I find methodology quite right. One point for simple organization. I think all projects the workshop anyway. We could use these events at least in a hybrid way to update ourselves on this project.
Well, actually, this is an excellent. Maybe we could ask Phoenix and the leaders that are the dissemination managers and implementation managers of a number of the projects, to communicate with them. Probably we can have a common hub or some kind of a social medium or a repository where all the partners of all the projects could have access to see what is coming up. If there is a workshop organized by one of the projects, or if there is a publicly available, this would make communication with the access much faster, rather than going, for instance, to the websites of the projects. So probably we could discuss this. So we have a common link or a mass mail that informs all the partners of all the consortium, of all the consortia, that there is a workshop organized by Project X on this topic. You are invited to attend, or we will have this meeting, or the projects that an advisory board meeting, which is open, they can, the partners can be invited for those that are interested. That's very good. So, any comments from the ones that are listening to us from their home or from their office? If not,
Maybe just
oh, sorry, yes, please.
no, it's just a final comment sorry, has an impact of this work. We discussed several times, Maria, with you and Peru, that also the impact on like standardization, meaning on the norm, which is totally missing in terms of integrated solution. So I think this work we are doing could really facilitate the creation of then a dedicated, let's say, standard, or really to facilitate the application of such a solution. So it was just to emphasize, let's say, what you said. And thank you by my side, and keep in touch.
One of the common activities that we could do with all the projects, organize a workshop, inviting some experts or from industrial partners that are already in the market with prefabricated components, not hybrid prefabricated components, to see what is the potential of going towards a common standard. Also, as you know, in most of our projects, it is a requirement of the cost to support the improvement of the LCA standard, to include options and visions for this kind of hybrid prefabrication. So that's also one topic that we have to deal with. So there's still a lot of work to be done, but it will be done on a step-by-step basis. So thank you very much. I wish you a nice and relaxed afternoon. It has been very useful and very productive workshop. It lasted longer probably than what we had anticipated, but the interaction was very good. And thanks, of course, to Sophie for being here and with her positive attitude having helped us to solve all the technical problems. And last but not least, to Anisha, who has been multitasking for the last 3 hours. So thank you all for the contributions and the participations, and we will come back with more ideas and progress. Thanks, and have a nice day to all of you.
Bye.
Thank you.